can do, Genique. This is our next question. So in this question he has asked, if you observe this question, a right circularly polarized wave is incident at an angle of 60 degrees normal on an air dielectric interface. Okay? The question is given as 60 degrees normal to the normal. Yes, 60 degrees angle to the normal, right? Okay? Normal on an air dielectric interface. It is given in GATE 2007. It's a very good question. Okay. So now a right circularly polarized wave is incident at an angle of 60 degrees on an air dielectric interface. Okay. If the reflected wave is linearly polarized, okay, then the relative dielectric constant epsilon R2 is, it is given as right circularly polarized wave is incident. Okay, this is the figure given. Options are also given. Okay, so if you observe this, it is incident, the EM wave is incident. Which kind of EM wave? Right circularly polarized wave is incident 60 degrees normal to this, 60 degrees with respect to the normal onto this interface. So this is the normal. So it is making an angle of 60 degrees with respect to this normal, and it is entering into the second medium. Now what he has given that it is the reflected wave is what? Linearly polarized. It is a linearly polarized wave. It is given. The reflected wave is linearly polarized wave. In the question I think it is included. Yes, I didn't written here. It is a linearly polarized wave. Linearly polarized wave. So one is right circularly polarized wave. So you have to observe that which kind of incident it is. It is obliquely incident on this interface. Okay. Suppose if there is a normal incidence, there will not be any problem. Okay. We can find the dielectrics by using dielectric constant by using the what? The reflection coefficient also will be given there. Okay. And you can also find epsilon 1 and epsilon 2. Okay. Eta 1 and eta 2. Any one of these given will be given, or reflection coefficient will be given. Okay. So if it is incident and it is transmitted and it is reflected, in the normal incidence there is no problem. If the EM wave is going like this normal to the interface, then there is no problem. Or if the EM wave is coming like this, then there is no problem. Okay, you can happily write. Now the thing is, here it is obliquely incident. Okay, it is making an angle with respect to the normal. So if it is making an angle with respect to the normal means we have to go for the oblique incidence case. So there exists, see, the thing is we have to go to one concept, a new concept here. In the oblique incidence there exists oblique. In the oblique incidence there exist two kinds of angles here. So one is we will define two kinds of angles. Okay, the angle of incidence. Okay, if theta I is equals to theta C, second one is theta I. When it is incident with some angle, if theta I incident angle is equals to theta C, if theta I is equals to theta B, it is called as a critical angle. It is called as the Brewster's angle. Critical angle, it is called as the Brewster's angle. Okay, it is called as the Brewster's angle. So what happens at the critical angle? At the critical angle, what happens? At the critical angle, there is no reflected wave, there is no transmitted wave. Okay, there is no transmitted wave. What happens at critical angle? If I project with the critical angle, okay, incidence with the critical angle theta c, what happens? It will go through the transmitted wave go through the interface. Okay, so if I increase greater than the theta c, what happens? It will be reflected. The total internal reflection takes place. So that means there will not be any transmitted wave, no transmitted wave, no transmission takes place. Okay, so the angle at which there is no transmission, that is called as transmitted into the second medium, is called as the critical angle. Okay, now at theta I is equals to theta b, what happens here is there is no reflection. There is no reflection. Okay, so which kind of wave will not be reflected? So that is called as a p polarized wave will not be reflected. Okay, so that means the reflection will be, it is a p polarized wave. P polarized wave will not be reflected. So what is meant by p polarized wave? You have to note this. Okay, the p polarized wave will be reflected, will not be reflected. Okay, so at theta I equals to theta b, at the critical angle, p polarized wave will not be reflected. Okay, so what is this meaning of this p polarized wave? Okay, so suppose if there is an interface, okay, if there is an interface like this, it is the interface. Suppose if an EM wave is making an angle, is incident with an angle of, with some angle like this, with respect to the normal, some theta I, and you know, and this will be reflected, some portion reflected and some portion will be transmitted. This is theta t with respect to normal and that is theta r. Understand? So this is the EM wave. Now if the electric field, if this is the EM wave direction, suppose if the electric field, already you know, the electric field will be perpendicular to this, always the propagation direction, it is the propagation direction, EM wave. Then what will be the magnetic field? The magnetic field will be like this. This one will be the magnetic field. This is the magnetic field, black pen. This is the electric field and this is the propagation. So perfectly they are following orthogonality. Okay, this type of wave is called as, so this is one case. So this is one case of oblique incidence. Suppose if the wave is incident like this. Suppose if the wave is incident like this, how it is incident? Let us suppose it is incident like this. This case is over. Okay, it is making an angle theta I and some portion will be reflected. Okay, this is, it is called as EI. Okay, it is HI. So it will be what? It is ET. It will be HT. Okay, no need to write this. This is also for the same next one. Okay, this is HT. This is how it would be. This would be ER and it is EHR. So this is one case and this may be one case for the oblique incident. Suppose if the electric field is now in this direction, electric field is now like this, EM wave is going like this, electric field will be like this. How the magnetic field will be? The magnetic field will be like this, HI, and this would be EI. Okay, this is HT, HR, and this is ER, and some portion will be transmitted like this. Okay, now what happens is, if you observe this, in this is one case possible, then this is one case possible. This is theta R, theta T. Okay. Now, see, if you observe this electric field is on the plane of incidence. It is the plane of incidence. Suppose if it is X, Y, it will be XY plane. The electric field is like this. The electric field is lying on the plane of incidence. Okay. This is also called as the plane of incidence. How the electric field is oriented? The plane of incident, it is oriented on the plane of incidence. Okay, it is oriented on the plane of incidence. It is also called as vertically polarized. It is also called as vertically polarized. It is also called as perpendicular polarized, or also called as p-polarized wave. It is also called as the p-polarized wave. Understand? Now come to this. If you come to this, this is E, but this E is parallel to the horizontal to this. This is a sheet. It is not just a line. It is a sheet. It is horizontal to this sheet. It is horizontal to the sheet. So if it is horizontal to the sheet means, so we can say this is called as, it is horizontal polarization. It is also called as surface wave polarization. It is also called as S-polarized wave. Okay, it is called as S-polarized wave. So if the wave is polarized like this, okay. So even though any of the ways it is polarized, so some portion of energy is transmitted, some portion of energy is reflected. So there will be reflection coefficient exist. So we have to define the reflection coefficient. So how can we define the reflection coefficient for the normal incidence? For the normal incidence, the reflection coefficient will be what? Eta 2 minus eta 1 divided by eta 2 plus eta 1. So this is the reflection coefficient. So but this is for what? Normal incidence. This is for normal incidence. But this is not possible. This cannot be applicable while we are going for the oblique incidence. Okay. So because there exist two kind of polarizations here. Okay. So depending on the polarizations, the orientation of the electric fields, the reflection coefficients will be changed. So that's why you have to concentrate, or we have to concentrate how the wave is polarized. Okay, so now we define the surface, the reflection coefficient for the surface wave polarization, a p polarized wave and s polarized wave. Okay, I hope you clear. Why I am saying this story means you should be comfortable while solving these kind of problems. Okay, so you should not be missed these kind of questions. Okay, now there are two kinds of polarization. One is S polarized wave and P polarized wave. So for that I am defining the reflection coefficients. The reflection coefficient will be, it is eta 2 minus eta 1, right? So eta 2 into secant theta t minus, or you can also write like directly like this, cos theta I minus eta 1 cos theta t divided by eta 2 cos theta I plus eta 1 cos theta t, where theta I, theta t are the what? The incident and transmitted angles. The incident and transmitted angles. This is the reflection coefficient for the S polarized wave. Similarly, the reflection coefficient for the P polarized wave is defined. Eta 2 cos theta t. You can easy to remember also. Eta 1 cos theta I divided by eta 2 cos theta t plus eta 1 cos theta I. Okay. In the normal incidence, theta I, theta, see what happens? There is no theta I, theta t will be what? What happens? They are same. Okay, so in the normal incidence, what happens? The theta t will be it is making an angle how much? It is making an angle. So here these two terms will not be presenting there. Okay, see theta cos theta. See, you will get what? This one will be equals to eta 2 minus eta 1 divided by eta 2 plus eta 1. Okay, because in the normal incidence, theta I is equals to theta t like this. Theta I is equals to theta t. Okay, it is equals to theta r. So that is the thing. So if theta I is equals to theta t means what? This all things will get cancelled. Okay. Now, so in this you have to remember this. So from the above, so what is theta? Suppose if I write eta 2 is equals to eta 1 is equals to what? I can write eta 1 is equals to root over mu by epsilon 1, because I am taking same kind of mu here. Okay, because a non-magnetic material, it will be like this. Okay, so eta 2 is equals to root over mu divided by epsilon 2. So if I write this, what it will be? This is equal to root epsilon 1 cos theta I minus root epsilon 2 cos theta t divided by root epsilon 1 cos theta I plus root epsilon 2 cos theta t. Okay. So from this, what can I write? Cos theta I. I am writing this cos theta t. So by using Snell's law, what the Snell's law saying? From Snell's law, it is also from Sin theta I divided by sin theta t is equals to what? Root epsilon 2 divided by root epsilon 1. So from this, what is sin theta t? Sin theta t can be is equals to root over epsilon 1 divided by root epsilon 2. It will go like this, sin theta I. Okay. So from this, what is, so wherever, so from this what can I write? So cos theta t can be is equals to what? 1 minus sin square theta t root. Understand? So from this, cos theta t is equals to root over 1 minus sin square theta t. So what is sin square theta t? So I can write this can be is equals to root over 1 minus, what is sin square theta t? Epsilon 1 divided by epsilon 2 sin square theta I. So this is the cos theta t. So if I put this equation here, so if I write this, then what I will get? This is epsilon 1. What I am dividing with the epsilon 1. Then this will be cos theta I minus root epsilon 2 divided by epsilon 1 cos theta t. Cos theta t can be written as what? This is, so this will be equals to what? 1 minus epsilon 1 divided by epsilon 2 sin square theta I divided by, what about this? This one also be divided cos theta I plus root over epsilon 2 divided by epsilon 1 root over 1 minus epsilon 1 divided by epsilon 2 sin square theta I. Okay. So I can remove this now. So now from this, what can I write? This is equals to cos theta I minus root over, if I send this into this, epsilon 2 divided by epsilon 1, if I send into this, these two will get cancelled, minus sin square theta I divided by cos theta I plus root over 1 minus, not 1, this is epsilon 2 divided by epsilon 1 minus sin square theta I. So this is what? Gamma S. So this is the expression in terms of only just what I am trying to do, that is I am converting it into the incident angles. So it was a function of incident and the transmitted angles. Now only I converted into incident angles to prove that only I have taken in terms of theta I is equals to theta C or theta I is equals to theta B. So that's why I am converting into incident angles. Okay. So similarly, this is what? The gamma S. So what will be the gamma P? The gamma P will be, how much you will get? The gamma P. It is gamma S, then the gamma P, it's, we are right? Yeah, we are right. Gamma S is correct. Cos theta I minus root over epsilon 2 divided by S. Right. Now, what is gamma P? The gamma P can be written as epsilon 2 divided by epsilon 1 cos theta I minus root over epsilon 2 by epsilon 1 minus sin square theta I. divided by epsilon 2 divided by epsilon 1 cos theta I plus root over epsilon 2 by epsilon 1 minus sin square theta I. So this is the expression for the p polarized wave. Similarly, we have to do that. Okay. So now what happens? What if any of these two is 0? Suppose if I want to make any of these two is 0, what happens? Any of these two is 0. Suppose if I make this gamma p is 0, if what happens? If it is 0 means it will be 0. So from this what can I write? Epsilon 2 divided by epsilon 1 cos theta I is equals to root over epsilon 2 by epsilon 1 minus sin square theta I. If you square this, you will get sin theta I is equals to root over if you write this sin theta I is equals to epsilon 2 divided by root over epsilon 1 plus epsilon 2, or directly you can write tan theta I is equals to root over epsilon 1 epsilon 2 divided by epsilon 1. So this, the angle of incidence at which theta I, if theta I is equals to theta b, if theta is equals to 0, then we are naming this as theta I is equals to theta b. If angle of incidence, if the reflection coefficient is 0, then we are naming that one as theta I is equals to theta b. So you can also write theta b here. Okay, so this is theta I. So from this what can I write? This is theta b. If you simplify this, you will get this. Okay, so now what happens? Or you can also write this is also, we got what? Sin theta b can be written as root over epsilon 2 divided by epsilon 1 plus epsilon 2. You can also write like this. Okay, these two are same. Simplify that. So this is called as the Brewster's angle. This is called as the Brewster's angle. So theta b is equals to tan inverse of root over epsilon 2 divided by epsilon 1. This is called as the Brewster's angle. The angle of incidence at which the p polarized wave is not existing, called as there is no reflected wave. Okay, that means what? There is no reflected wave. Reflection of the p polarized wave is not existing. It is for what? It is the reflection coefficient of the p polarized wave. So reflection coefficient of 0, if theta I equals to theta b, that means what? There is no reflection of the p polarized wave. Okay, this is called as Brewster's angle. Okay, at Brewster's angle, no reflections, no reflection, only transmission takes place. Which wave? Only the p polarized wave will be transmitted. There is no reflection. Okay. Now what if gamma s is equals to 0? If gamma s is equals to 0, what happens? If gamma s is equals to 0, then what we can say? If gamma s is equals to 0, what happens? This is 0, this is 0, and this is equals to this. Okay, so from this cos theta I is equals to, okay, cos square theta I is equals to what? Epsilon 2 divided by epsilon 1 minus sin square theta I. and these two will get cancelled because same. So from this what can write? Epsilon 1 is equals to epsilon 2. So that means it is for the same medium. That meaning it's what? The meaning of this is a same medium. If medium is same means there is no reflection, refraction, or transmission concept. Okay. So for this the Brewster's angle will not be existing. So for this we won't define any kind of Brewster angle because epsilon 1 is equals to epsilon 2. So this is called as the Brewster angle. Okay. So now we got this is the Brewster angle. So now come to the question. So at Brewster's angle, what happens? There is no reflection. Okay. Of the S polarized wave. So suppose if you take any S polarized wave, suppose or P polarized wave. Suppose if you take any right circularly polarized wave, the right circularly polarized wave will be having S polarization and P polarization wave. The right circular polarized wave will be consisting S and P polarized waves. Okay. The right circular polarized wave will be having S and P polarized waves. And they will be the component of the S polarized wave will be equal to the component of the P polarized wave. Okay. The components of the S polarized waves will be equals to the components of the P polarized waves. You have to note this. Okay. So what happens? That means the magnitude of the S polarized wave will be equal to the magnitude of the P polarized wave. Vertical component is equal to the horizontal component. That is the meaning of that. Okay. So that means vertically polarized wave is equal to the horizontally polarized wave. Vertical component is equal to horizontal component. Okay. So this is the thing. Now come to the question. Okay. And this is equal to what? S is equals to P here. S component is equals to P component. Okay. For what? For a right circularly polarized wave. Now come to this. Now come to this. And here only, if any linearly polarized wave is there, for the linearly polarized wave, only S polarization exists. Only S polarization will exist. No P polarized wave. Okay. For elliptically polarized wave, what happens? S polarized S component and P components are not equal. The vertical component is not equal to the horizontal component. So you have to note this. If you know this, this is very simple. See, observe this. It is a right circularly polarized wave incident at an angle of 60 degrees to the normal of on an air dielectric surface. If the reflected wave is linearly polarized wave, then the relative dielectric, see, it is a right circular polarized wave is given, some portion of energy is transmitted, some portion of energy is reflected. Okay. Now that means what? Here what is happening? Right circularly polarized wave means what? S component is equals to P component. Okay. S component is equals to P component. But here it is linearly polarized wave means what? Linearly polarized wave means only S component will exist. Okay. What about P component? P component is not there. The P component is not there means the total P component will be existing here. Okay. The total P is transmitted because why? There is no reflection for the P polarized wave. They are existing P polarization and S polarization. Okay. Here what happened? Only the P polarized wave is transmitted. Okay, because the meaning of this one is what? Only the linearly polarized wave means what? Only the S polarization exists. So S component only existing for the linear polarized wave. The meaning of the linear polarized wave means that one. Only S polarized wave is existing. So that means there is no reflection of the P polarized wave. That means the total entire the P polarized wave is transmitted. So this is the P component. Okay, S component means we cannot say that it is total S component will be transmitted. Okay, so that means what? Because these two are the two mediums. Okay, because epsilon 1 is not equals to epsilon 2, what happens? There will be some reflection. The S polarized wave will not be reflected if and only if epsilon 1 is equals to epsilon 2, and there will be reflection in the transmission for the S polarized wave. So S polarized wave will be existing, S component will be existing, and P component will be existing. Okay, so S component will be existing, P component will be existing. But observe this. Is these two are equal? See here, we are getting right circularly polarized wave. S component is equal to P component. But here, what happened? Only the P component is blocked here. The total P component is sent back. So that means these two are not equal. Some of the S component is going out, some of the S component is coming out. But entire P component is coming here. So that means, observe this. We can say that this is what? For elliptically polarized wave, these two are not equal. So that means this is what? This is elliptically polarized wave. Okay. So that means what? What's happening? Here only the S polarized, linearly polarized means the P polarized wave is blocked. The P polarized wave will be blocked if and only if theta I is equals to theta B. Okay, the gamma P will be 0. That means the reflection of the P polarized wave will be 0. So from this, at what angle it is becoming linearly polarized? At what angle it is linearly polarized? That means it is indirectly given, that is, it is directly given, that is, it is 60 degrees. Theta B has given 60 degrees. Okay. Why? Because there is no P polarized wave means there is complete transmission of the P polarized wave. That means we are projecting this angle with the Brewster's angle. So tan 60 degrees is equals to root over epsilon 2 divided by epsilon 1. Okay. So here tan 3, this is root 3. This is equals to what we have to find? We have to find the relative dielectric constant. What is the epsilon 1? This is epsilon 1 and this is epsilon 2. So epsilon 1 and epsilon 2. Already we know this is what? This is equal to root over epsilon naught epsilon R2 divided by this is what? Epsilon naught. So from this, what can I write? Epsilon R2 is equals to 3. The answer is 3. So like this, you have to solve these kind of questions. I hope you got this. Okay. So if you know this concept, it is 1 minute. If you are seeing that it is only linearly polarized wave means only one polarization existing, S polarization only. So the P polarized wave is blocked. The P polarized wave is what? It is transferred. So in this, the P polarized wave is in this direction is blocked means it is totally transmitted. If it is, but S polarized wave will be what? Transmitting and reflecting and transmitting. The F polarized wave cannot be what? Totally transmitted or totally reflected. Okay. So some portion of S polarized wave will be reflected, some portion of P polarized wave will be reflected. But the total, so some portion of S polarized wave will be reflected, some portion of S polarized wave will be reflected. But here, if we incident with the Brewster's angle, the total P component will be reflected, the transmitted. There is no reflection of the P polarized wave. Okay. So this is how you have to encounter this type of questions. Okay. I hope you got this. Thank you.